find in the course in the SI resources section. So if you go to the SI resources, at the bottom you have this SI worksheet that we're doing, and I'm not going to do, if you read the email you know this, but if you didn't, and most people don't, I'm not going to do all of the problems on this, but if you want to do more for extra practice, feel free to do them and send them to me and I'll check them for you, or you can come by my office and have me check them. I'm not going to sit down and work them all for you individually, but if you've given it a shot and want me to look at it, I'm happy to do that. Or if you've given it a real shot and you don't have any clue, but you've really tried, you know, it's just, I'm just asking you to make the first step on doing it. So, so first we need to talk about what it means when we talk about product of sums and sum of products. And so if you look on the worksheet that I gave you, I also have for reference on the last page, or second to last page, I have the min terms and the max terms for sum of products and product of sums, and the min terms are products and the max terms are sums. And if you look for the min term, so a min term where you have x1 bar, x2 bar, x3 bar, that's min term 0, and for max term it's the complement of those. So rather than x1 bar, it's x1, and rather than having a product, you have a sum. So this first one says determine the minimum cost product of sums expression for this function. The first question on the worksheet. And so when I look at it, I see that it's defined with a lowercase m, and a lowercase m is used for min terms, so a lowercase m is used for min terms. So this is asking for the minimum cost product of sums, but what we're given here is a sum of products. And we can tell because we've got the sum symbol here, and we're looking for a product of sums. And so the product of sums is going to be, so the product of sums will have the max terms that you don't have the min terms for. And so this capital pi here, standing for product, it'll have the max terms 1, 3, 5, 6, 7, 8, 9, 11, 13. And so that equals the same as the sum of these min terms. And so max term 1, if we look at the last page that I had just a minute ago, so max term 1 is x1 plus x2 plus x3 bar, and I guess I didn't put them on here for beyond row 7, so I'll need to show you how to get those. Okay, so let's say that I have 4 variables like I do here. So x1, x2, x3, x4, and I want to list out all the possibilities of zeros and ones that I could have. Now I know a little shortcut for this and this gets them all in order, and there's no theory behind it. It's just a shortcut. So I have 4 variables. That means I have 2 to the 4 different possibilities, or 16 different possibilities. For x1, I'm going to make half 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8 half zeros and half ones. 1, 2, 3, 4, 5, 6, 7, 8. And then for x2, I'm going to do groups of 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then for x3, go by 2s. And then for x4, I just alternate every one. And what I've done here is I have written the binary numbers from 0 to 15. So this is 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And if I want to get the min term for one of these, I can just look at it. So like min term 9, so min term 9, if I look at 9, that has x1 not complemented, x2 complemented, x3 complemented, and x4 not complemented. Max term 9 will be the opposite. It'll have x1 complemented plus x2 not complemented plus x3 not complemented plus x4, oops, this one was not supposed to be complemented, x4 complemented. So max term 1, I can go to row 1 here, and I can say that that is going to be x1 plus x2 plus x3 plus x4 bar. Max term 3 will be x1 plus x2 plus x3 bar plus x4 bar. Max term 9, I just wrote that one. That's x1 bar plus x2 plus x3 plus x4 bar. Max term 11 is x1 bar plus x2 plus x3 bar plus x4 bar. And max term 13 is x1 bar plus x2 bar plus x3 plus x4 bar. Okay, so now I want to get the minimum cost product of sums. So I want to minimize this now, but I still want to have the product of sums. So I still want to have sums that are multiplied together. Now, if I look at this term and this term, what do you notice? And the x2, one of them is not complemented and one of them is. And whenever you have that, you can just ignore that term, because that's basically saying, this one is saying or x2, and this one is saying or not x2. Oh, well, it can be either x2 or not x2, then you don't really care what x2 is. So I can write it like this. Okay, now do you see any others that differ just by 1?
First and second term differ by x3.
Yep. So I can do x1 plus x2 plus x4 bar. And so I've taken care of this one, this one, this one, and this one. And now, is there anything I can do with that last one?
You could duplicate the third term so that you can combine it into the fourth.
Say that again?
So you previously used the third term and combined it with the fifth term.
Oh, right, yes. So I can just reuse the third term. You said duplicate it. Okay, got it. So you're saying, I would say reuse it, and so you were saying I can use the third term again. And so you can reuse them, and notice that this time they differ only by the x3, right? So that would be x1 bar plus x2 plus x4 bar. Okay, so now when I look at this one and this one, what can I do with those? So it's just x2 plus x4 bar, and then x1 bar plus x3 plus x4 bar, and that's as simple as I can get this and still have a product of sums. You will learn later a way to verify that you have the product of sums, but that you have the minimum one, but that would be it for here. Okay, let's see. Let's go to problem. Let me stop and save this.